Hi, this is a video explaining for Math 2-3. This is explaining the quadratic formula. This is the formula that we're using to solve the case 3 problems. The ones where it has all three parameters A, B, and C, and they're non-zero. The quadratic formula is written like this: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. By the order of operations, we need to find what's here inside the square root sign first, and then square root it before we worry about any of the other stuff. So we're always going to start by first finding b squared minus 4ac. To do this, we have to start with the equation in standard form, arranged like this, with all terms combined, all sets of parentheses expanded, if there are any. In the examples that we're going to look at first, there aren't any, but we start with a squared, a times x squared, b times x, and c, where a is the coefficient of x squared, not this whole term, just the coefficient, just the number in front of it, plus bx plus c, the constant. Start with an example. We're going to find the x-intercepts, also known as the solutions, the zeros, or the roots of this quadratic equation, x squared minus 7x plus 10. We need to find the values of a, which, since there's no number right in front of the x squared, that has to be 1 times x squared. So a is 1. B is the coefficient of the x term, so it's this right here, negative 7, not just 7. It's very important that that's negative. And C equals the constant, 10. So we had A is 1, B is negative 7, and C is 10. We're going to just plug those numbers into b squared minus 4ac. So that gives us negative 7 squared minus 4 times a, which is 1, times c, which is 10. It's really important to note that negative 7 times negative 7 has to be a positive number. If you just type negative 7 squared into a calculator, you'll get negative 49, which is the wrong answer. Use the parentheses, and we get 49 minus 4 times 1 times 10 is minus 40, which equals 9, and we need to find the square root of that. Square root of 9, of course, is 3. We talked earlier about how it's both positive and negative 3, and then in the quadratic formula here with this plus and minus sign, that's how we get two answers. And with quadratics, you know you're looking for two answers for x. So we've got negative b plus or minus 3 all over 2a. B was negative 7. It's important to know that the negative of a negative number is 7, plus or minus 3 over 2a. A is 1, so this is just 2. So we've got two answers, x equals and x equals. This is 7 plus 3 all over 2, which is 10 over 2, which is 5. X is also 7 minus 3 all over 2, which is 4 over 2, which of course is 2. So those are the two x-intercepts for this problem. We should confirm our answers by plugging them back into the original equation. The original equation was y equals x squared minus 7x plus 10. And if we plug 5 into this expression for 2, we should get 0, because we're looking for the roots of the equation. If we plug in 2, we should also get 0. Five squared minus 7 times 5 plus 10, that equals 25 minus 35 plus 10, that equals negative 10 plus 10, which equals 0. So 5 is correct. I leave plugging 2 into the equation to confirm that it yields 0 as an exercise for the viewer. Graphing this function in my calculator app also can confirm the answers. See, the scale on this graph goes from 1 to 10. Here's the function x squared minus 7x plus 10, and you can see that it crosses the x-axis at 2 and at 5. It crosses in 2 different places. That's how we can see that there are 2 solutions to this, and our algebra steps match the graph. The quadratic formula is very useful when the numbers that we're working with are not pretty, like 2.5 and 35 and negative 16 are the parameters here. The numbers for this are not going to work out as well as example 1 did. These numbers are not in the right order. Notice that in this equation, the t squared variable is written last. It's important that you don't fall for the trap where you just think that A is the first thing, B is the second thing, and C is the last thing. It doesn't matter what order they're in, it matters what variable they're connected to. So in this case, A is negative 16. It's the number that's attached to the t squared, not the first one. B is 35, because it's with the t variable, no exponent on the variable, and C is 2.5. Putting that into the quadratic formula, we start by doing b squared minus 4ac, and in this case that's going to come out to 35 squared, which is going to be a fairly large number. Notice it's positive, so we don't need the parentheses, but it might be a good idea to have them there anyway. Minus 4 times a, which is a negative number, so now we've got a negative times a negative, which is a positive, times 2.5, and this is going to need some calculator help. Looking at the calculator app for doing some of these calculations, I've put in 35 squared minus 4 times a times c, just plugging in the values that I get from the standard form of the equation, and that comes out to 1,385. I take the square root of that, and I get the number I'm looking for. It is 37.22. We'll find the values that go along with this. B is 35, so we've got negative 35 plus and minus 37.22 all over 2 times a, where a was negative 16. So that's fairly complicated. We're going to need the calculator again to figure it out. I used my calculator app to plug in the rest of the equations that we have. We had negative 35 plus 37.2, all divided by negative 32. I went ahead and simplified 2 times negative 16 for the denominator of this. You have to make sure that you use correct order of operations when you're putting this into the calculator, or else you will get wrong answers. It's better to simplify it algebraically first and then come up with what you put into the calculator. and that comes out to negative 0.07, rounded off to the second decimal place. And then we also had the other value of x. You see the only difference between these two expressions is one is plus and one is minus. So this is negative 35 minus 37.22, and that gives us a value of, divided by negative 32, and that gives us 2.26. So those are our two values of x. X equals 2.26. Notice that that's a positive, and x equals negative 0.07. You have to have both of the answers, even though in this case this problem might be about throwing a ball, hitting a baseball, firing a gun. Any of those situations use the equation for ballistic motion that we were looking at, and in that case only the positive time would make any sense. But we're just looking at solving quadratic equations and finding the x-intercepts, so you have to use both of these. Using the calculator app to examine the function, again, 2.5 plus 35x minus 16x squared. Of course, I have to use x's instead of t's in the calculator app. We can see that this gives us a parabolic motion, like for a thrown baseball or something. And down here I use the trace function to show the zeros, and we can see that the x value is in fact 2.26 when the pointer is right on the x-axis. The calculator uses 1.9 times 10 to the negative 11th, which is a number so tiny, might as well be 0. I really wish that this app would just use 0 there instead of a teeny tiny number that's very close to 0, but you can't have everything. So 2.26 is one of the zeros. We saw that the first one was negative. If each tick mark on this scale is 0.1, then that's very believable that that x-intercept there is negative 0.07. So we've used the quadratic formula to examine the two roots of a quadratic equation. There's more to know, but that will be in a separate video. The quadratic function to show that quadratic formula to show that there are two values of x that we're looking for is often broken up like this into negative b over 2a plus square root of b squared minus 4ac over 2a, and the same thing, negative b over 2a minus all that. Notice the difference in these is only that one is plus, one is minus, but this is equivalent to the original form of the quadratic formula that we saw. That's enough for one video. There will be another video with more examples using the quadratic formula coming soon.